Hello everyone, welcome to another video. In this video, I will talk about another high priority incident that I was part of. This issue is related to how missing MongoDB indexes caused 90-second API latency in our application, in one of our applications, which is used to launch critical events. So let's get started. So during a critical event launch workflow, so as I mentioned that this application that the users use, it is used to launch few events, and the events actually use some templates, and then within the templates we have some custom variables. Okay, so this issue is related to that. Let's talk about it in much more detail so that we understand each and everything of it. So during a critical event launch workflow, users experience consistent failures while creating events using predefined templates. These templates include task lists and dynamically evaluated custom variables. So this is actually related to application. So this is the type of application that the users were using. So we had a specific template which began taking over 90 seconds to process, which led to API timeouts at the application layer. So from a user perspective, event creation appeared to have failed. So the users who were trying to launch these events using this template, within the template, whenever they were choosing any custom variable, they were seeing timeout errors, API timeout errors. Okay, so then the issue was raised, and we had a call. We all joined. The application team started investigating from their end. So they verified that events were successfully created in the database. So even though the users were seeing API timeout errors on the front end, but events were actually getting created in the database, associated entities also persisted. So whatever they created, it was actually persisted into the database as well. So only the API response was timing out and not the actual processing. So this clearly indicated a latency bottleneck rather than a functional failure. So initial observations, systematic testing was performed across multiple combinations of templates, task lists, and custom variables. So they started to see they started to perform various combinations of templates, task lists, and custom variables just to see which one is failing. Okay, so the key findings were the templates without custom variables, they performed normally, so there was no issues. Latency increased significantly when custom variable processing was involved, and the issue was reproducible, and we were able to isolate the issue to a specific execution path as well. Okay, now to move beyond assumptions, what the application team did, they enabled some enhanced logging on the application level. Okay, and all these I'm talking about a Java Spring Boot application. So this is a Java Spring Boot application. So within their main application code, they enabled the logging, they raised the MR. Okay, then merged it on urgent basis, and it was only deployed in the impacted region. So impacted region was EU Central 1. Okay, so this is to focus on request level breakdown. And just as an example, so this is how Grafana dashboard for latency would look like. This is just an example screenshot, but I think it's going to give you some idea about how this latency dashboard in Grafana can look like. Okay, so this is just one example. So now root cause analysis, if I talk about, so we also did detailed tracing, which revealed a critical insight that 5 to 6 database operations related to custom variable were responsible for 90% of the total request latency. So this was the main root cause. Okay, then so in this case we were able to identify that something is not working on the database level. So then we involved our database reliability engineering team, DRE team, which identified that queries on the custom variable collection, because we are using MongoDB. In MongoDB we have something called as collections. and within collections you have the documents. So this is related to MongoDB concepts. So the queries on the custom variable collections were executing full collection scans, which means that there was no indexing. So whatever these custom variables, like whenever there was any query that was run on these custom variables, then the entire collection was being scanned. Okay, so there was no supporting indexes existed for frequently queried fields. So on a high level, if you have indexes, then you can reduce your search area within this MongoDB collection. Okay, so less area means less time to search, and it's going to decrease the latency as well. So we did not have any indexes on these custom variables. So each time any query was made on this custom variable, it was involving to scan the entire collection in the database. So as data volume increased, a query execution time degraded exponentially. Okay, and in general, this is a classic on scan problem versus O log n indexed lookup scenario. So this is what it's called. So once again, this is all related to database, but this was the issue. So if I just want to explain this specific scenario, without an index, the database has to check every record to find what it needs. That's going to slow. That's slow and grows linearly as your data increases. So with an index, the database uses a structured lookup, okay, like a sorted directory. So just like you have a lookup, we look up in an Excel. So similarly, you can have a structured lookup in this database also with the help of indexes. So it helps to jump directly on the required data in much fewer steps, making it significantly faster. Okay, the meaning of this particular lookup scenario. So why missing indexes cause this issue? In MongoDB, indexes function similarly to a lookup structure, as I mentioned, also called B tree, that allows database to avoid scanning every document. So without index, MongoDB performs a call scan, or it's also called collection scan, where every document is inspected. Latency grows linearly with dataset size. When you're using index, MongoDB uses something called as IX scan. Okay, it's called index scan basically. So when you're using index, you can directly jump to the matching documents much faster. So the query time becomes logarithmic and highly efficient. Okay, so this is all related to the MongoDB database concepts. So if I talk about an example scenario, suppose the queries were filtering on this particular block. So without an index, the MongoDB is going to scan millions of records. Okay, but if you have a compound index, something like this, that event ID is 1, variable key is 1, then MongoDB can directly locate your relevant document. So now if I talk about the resolution part, the DRE team implemented a targeted indexing strategies on the custom variables collection. So this was the solution that they implemented. So if I talk about an example index gated, so once again, I'm not from the database side, okay, but whatever was done, I'm just trying to provide information on that. Okay, so this is how the index is going to look like. Okay, but it was all done by the DRE team, because here all the databases are managed by this team called DRE, Database Reliability Engineering Team. So the impact of this is the query execution time dropped drastically, API response latency reduced from 90 plus seconds to sub-second levels, and all the timeouts were eliminated. So how indexation happens in production? If I talk about the real world process, in a production grade environment, index changes are never executed ad hoc. They follow a controlled change request workflow. So on this also, we raise an emergency change request, and then all the steps that we wanted to perform were documented. Actually, the steps were documented later. We raised the change, but since the issue was urgent, so the DRE team performed everything, and then later they documented everything in the change request. In that change request, you have to mention your deployment steps, or the person who is executing the change, the person who is reviewing the change, what is your pre-implementation steps, what is your post-implementation steps, what are your verification steps, and then you have to mention what is the impact of the change. Okay, so all those things you have to mention in the change request workflow. So we followed that. The change was an emergency change, and we just like try to document everything after we were able to execute it and resolve the issue. Okay, so if I talk about some of the steps that they actually performed, so they were able to identify the slow queries. Okay, then analyze a query plan, something like this, and look for this problem where the entire collection is being scanned, and we optimize it using the ixscan method, where you're just scanning the particular index instead of the entire collection in the MongoDB database. The proposed index by the TRE team is to validate the cardinality, check index size impact, ensure no write performance degradation. Okay, so this was what they suggested. So once again, all these are database related. Okay, but in on a high level, if you have to explain this in an interview, you can just mention that the indexes were missing, due to which the entire collection was being scanned. The DRE team intervened, and they created the indexes, the right indexes that we required, and then the issue was resolved. The API latency was resolved just because of that. But if you want to learn about technical things, what exactly they did, this is what they did. Okay, so I'm also not an expert on these, but I'm trying to include as much information as possible from my end. And that's it. And then this is how they created the index. So in modern MongoDB versions, index builds are already optimized, but production clusters still require a careful rollout. Okay, and this is how they were able to validate their changes post deployment. Okay, once again, something related to MongoDB database indexes. Okay, so after the changes were done, we confirmed that ixscan is being used, and it was able to reduce the execution time. So now if I talk about some of the key learnings, is database performance can silently degrade APIs even when your business logic is correct. Okay, because initially if you see, the application team thought maybe something is not right within their application, or they have made some changes recently that might have impacted, but it all turned out to database queries being slow. So the timeout errors do not always indicate failure. They often signal latency bottlenecks. Missing indexes are one of the most common causes of production incidents. Observability, you have logs and tracing enabled. It is critical for isolating the true bottlenecks. Always validate query plans in production scale datasets. Okay, some of the key learnings that we were able to see from this incident. This incident highlights a fundamental truth in distribution systems. Your application is only as fast as your slowest dependency, and in most cases, that dependency is your database. By introducing the right indexing strategy, a critical production issue was resolved without any application code changes, proving once again that performance tuning at the data layer is often the highest return on investment optimization. Okay, so some of the things that we can remember from this incident. This was the incident I recently handled. I hope it was useful to you. So as I mentioned, you can like explain this in your interviews also. If somebody asks you like, what production issues have you handled, so this is my second video. I've already done one video where I explained another P1 incident that I was part of, and this was the second one recently happened. So if you can make notes on it, if you can prepare it well, I think you can explain this in the interview for DevOps and site reliability engineering both. All right, guys, that's all I wanted to cover. I hope this video was useful to you. If you like this video, then I have hundreds of videos on my channel. I have videos on DevOps, interview question and answers, site reliability engineering question and answers. I have a lot of projects as well. I have a lot of fundamental videos as well. I do have YouTube membership videos as well, but I do have a lot of free content also available on my channel. So to explore everything, have any feedback, any suggestions, you can always reach out to me in the comment section. All right, guys, that's all for this one, and I'm going to see you in the next one. Bye for now.